In this section, we'll talk about how the derivative shows us the rate of change of a function with respect to a variable. In other words, how does it show change? We already talked about the notation of the derivative and differentiation, what does the dx means, and the definition of the derivative. Basically, the derivative gives us the slope of a tangent line on the curve representing the function. So a function has a curve. We plot this curve on a coordinate system. Let's say this is the curve representing f of x, and the derivative is supposed to give me the slope of such a line. Slope of this line. Now let's discuss how this derivative can help us find the rate of change of a function with respect to a variable. Okay, so this here is a line with a slope of 0. This is another line. It has a positive slope. This line, the slope of this line is a bit higher than the slope of this other line. This line has a slope of infinity, and on the other side, this line has a negative slope. Let's say that its slope is a, and basically the derivative gives me the slope of lines. I can find the slope of a line on this point, the slope of this line. So using the derivative, I can find the slope of this line. And I also can find the slope of this line. And I also can find the slope of this line. So using the derivative, I can find the slope of these lines, these tangent lines on the points P1 to P4. We can see that this line has a positive slope and this one has a negative slope. The tangent line on the point P1, meaning this line, has more slope than this tangent line on the point P2, and the slope on the point P3, the slope of the tangent line on the point P3, has a slope of 0, this line here, and the tangent line on the point P4 has a positive slope, maybe even more positive than the slope of the tangent line on the point P1. Let's make an observation here. Whenever the slope of a line increases, it doesn't matter if it's positive or negative, we can see that the curve changes more. Let's plot in another curve. Let's say that this is the curve representing the function f of x, and I can find the slope of the lines on each of these points using the derivative. And we can see evidently that if the slope of the tangent line gets higher, then the change in the function f of x also gets higher. For example, in this point, we can see that the curve has quite a big change. Using the derivative, I can find the slope of the point here, the slope of this line on the point here, and the slope of this line will be quite high. But on the other side, if we took the slope of this line, the slope of this line would be 0. And we also can see that the change in f of x, we can also see that at that point f of x does not change. In fact, it has a maximum. After that point, f of x will begin decreasing. So the slope of these lines on each of these points will give me a negative slope. negative number, but the rate of change increase after the point here on the maximum will begin increasing and then will begin decreasing until we reach this point here. And on this point, the slope of the line will be again 0. So the slope of the tangent line can give me the rate of change of f of x. As the slope of the tangent line gets bigger, the rate of change of f of x will also be big.